Well, let's start our last portion of our discussion on filter design. Okay. So far we have discussed four different types of filters: low pass, high pass, band pass, and band stop filter or notch filter. Now we also saw active filter and passive filters, and they have some positive signs, and they have some negative sides. Okay, they have some limitations as well. Well, there are some other special types of filters as well, and we actually use them. They are widely used. The reason is that, okay, so far we have seen the ideal scenario, okay, but in the real scenario, they will look a bit different. For example, say, um, okay, so for example, for a low pass filter, we have actually seen the output of a low pass filter something like this. Okay, I have, this is my pass band. Okay, this was my pass band, this was my stop band. Okay, and this was my slope. Okay, this is what we call roll off. Okay, this is also called roll off. This is also called roll off. Okay, this is also called roll off. Now, but the thing is that in real circuit design, we will not get these types of output. We'll get some repos. Okay, and this is my pass band. In the pass band, you will find there are some repos here. Okay, some small repos there. Also in the output side, in the stop band side, there are also some repos. Okay, we'll not get this flat surface like we actually saw previously. Rather, we'll get some repos, and sometimes we don't want this kind of repos, and there are many other issues, some other issues. So for different, to handle different issues, we have designed, there are different types of filters for them. Okay, okay, we can actually design those filters in MATLAB, and these are a bit high level topic, so but still you should actually know the basics of those things. Now, so let's actually start with our five different kinds of filters. So the first is a Butterworth filter. Okay, now the Butterworth filter is the most widely used and very common. So it actually looks something like this. Okay, I have, sorry, Butterworth. Okay, I have this straight line, something like that. Then I have this straight ripple. Okay, so for a Butterworth filter, I do not have any ripples. Okay, in the pass band and the stop band, in both sides, we do not have any ripples. Okay, so and this roll off is actually 20 dB. So the, like previously, this roll off is actually minus 20 dB per decade. So this is actually very widely used, and we actually call it maximally flat. Okay, because we have this flat surface. Okay, we call it maximally flat. Maximally flat. Okay, and this is actually widely used in audio processing. Audio processing. Now this is the most widely used for the Butterworth filter. But there are some, and one of other things that we had 20 decibel, this one. Okay, we had 20 decibel roll off. Okay, but sometimes we may want actually a faster transition. So I have a transition, this is from this portion to this portion. This is the transition of the transition is occurring, and sometimes we want more faster transition. Okay, so this was my first one, the Butterworth. So if we want a little bit more faster transition, and the second one actually comes, this is my Chebyshev filter. Okay, the Chebyshev filter offers a much faster transition, but it has some drawbacks. Okay, the drawback is in the first one, Butterworth, I had this flat surface in the passband, maximally flat, but in the Chebyshev I do not have flat, rather I have some ripple, but I have a much, okay, I have a much steeper slope. Okay, so I have a very fast transition in the Chebyshev filter. Okay, now understand, the ripple is in the pass band. Okay, not in the stop band region, only in the pass band region, and this is very faster compared to this portion. Okay, so this is actually why we use Chebyshev filter if we need actually fast transition. And other thing is that there is also a allowable range. Okay, you can see, so how much we can actually allow this ripple. There is a limit that we can allow, and this in the positive side, and in the negative side we can allow this amount of ripple. Say for example, we can allow 0.01 decibel in the upper side, and minus 1 decibel in the lower side. Okay, minus 3 decibel is my FC. Okay, minus 3 is my FC. So this ripple has a allowable range. Okay, and another other thing is that uh, these ripples that we have in Chebyshev filter are actually equal. So that's why there is a particular name, we call it equal ripple filter. Okay, equal ripple filter. So we call them equal ripple filter. And the number of ripples, another thing is that the number of ripples that we have, number of ripples is equals to n by 2. Remember, n is the order of the filter. Okay, so see, if I have a like fourth order filter, okay, then the number of ripples that we will have here will be 2. Okay, so it's okay, you don't have to go into more details. So this is my two types of filter. One is my Butterworth filter, and the next one is my Chebyshev filter. Now the third one is that is called this inverse Chebyshev filter. So what is inverse Chebyshev filter? Now there we have this Chebyshev filter, we had the pass band, then this fast transition, then this stop band. And in inverse Chebyshev we have exactly opposite. Opposite means, so this is our third. Okay, this is our third. I have this pass band, but I have now a straight line. Okay, I have no ripples there in the pass band. Then I have a very fast transition, but now I have some ripples here in the stop band. Okay, in the stop band I have some ripples. So it is like exactly opposite to this one. I have no ripple in pass band, but we have ripple in stop band. So if you have application where you want pass band very flat, okay, you don't want any ripples there, but there can be some ripples in a stop band, then you can actually use this inverse Chebyshev filter. Okay, so this is my three types of filter. Now the fourth one, the elliptic one, this is a good one. The fourth one, we call it elliptic filter. Now elliptic filter is that I have ripple in the pass band. Okay, I have ripple in, no, like this. So I have some ripples in the pass band. Okay, and I have also some ripples in the stop band, but this transition is very steep. Okay, I have the fastest roll off. Okay, this roll off is the fastest among all these types of filter, all the filters that you have used. This is the most fastest transition that occur. So when you have the fastest roll off, that I need a very sharp cutoff frequency. Okay, like I have 50 hertz. Okay, I have 50 hertz and 100 hertz. Okay, very close, and I need a very sharp cutoff here. Okay, then we will use this type of filter, that is the elliptic filter. Okay, but the problem is this will create some ripples here, and this will also create some ripples here. There is some drawbacks also. Nothing is actually always the best. Now the first and the last one, this is my fifth one, that is my Bessel filter. So my Bessel filter is similar to my actually Butterworth filter, but the only difference is there is no, again there is no ripple in the pass band, there is no ripple in the stop band as well, but there is, I have a curve is the roll off is very lengthy, very slow transition. Okay, this is my 20 decibel, that is the normal one, and now I have a very like gradual transition, very long transition, and this is the maximum that actually occurs, Bessel filter. And this is actually used sometimes, it actually provides a certain amount of delay, and this kind of application you will learn in your actually next semesters, not this one, in your fourth year and third year, some high level courses you'll learn about the applications of these ones. So I think this is okay. These are the 5 different types of filters, the special types of filters. So I think it is clear. Now the next question is, so understand actually what the difference between these types of filters and why we can use them. And the other question is, the next question is how we can actually design these types of filters. Okay, we have designed like low pass filter and high pass filter previously, but how we can design, how can we design these special types of filter? Now when it comes to filter design, there is something in new that is called transfer function. Okay, I think you are familiar with it from your circuit 2 course, transfer function. Now transfer function is the relation, okay, relation between output and input, output and input. Okay, the relation between my output and input is what we call transfer function. So the relation is like v output divided by v input. Okay, and this has some value. Say if it is like 5, if it's like say a constant 5, so v output is like 5 times my v input. Okay, 5 times my v input. So my if v input changes 5 times, then V output will change 25 times. So this is the relation between output and input. Now when we actually design our filters, we actually look into the transfer function, what kind of transfer function that we want. Now transfer function is a concept that you will actually learn more details in your 4.1. There is a course on control system engineering. In that course you will actually learn how to actually show this transfer function in mathematical way. So I am not going to details in the explanation, that will take a long time. So for example, let's give me at least one example. For example, in Butterworth filter we can actually design like this way. So for example, if we want a low pass Butterworth filter, so I have this resistor and capacitor, right? A resistor and capacitor, this was my, and this was my input here, this was my input here, and then this was my first order low pass filter. Now let's make it second order. To make it second order, I have to add another branch, so like this, and a capacitor. Okay, this is my another branch, two branches. Now we want to actually to mitigate the well gain problem. Okay, we have to we actually add an op amp here, so make it an active filter. So this is my plus and minus. We add this one to the plus side, okay, and the minus side we add one resistor should be added here. This is my input resistor, this is grounded, another resistor here, and it goes to my output, that is my feedback resistor. This was my feedback RF, okay, and this was my RI. Okay, now the other question is, what we do in case of Butterworth filter is that this one this is my output of my first low pass filter, first portion. We actually connect it, okay, short it to my output side. That means this was my output here. So this is actually what we called a feedback loop. This is my feedback. Okay, I am getting the output, I am feeding the output back to my input again. In this portion I am feeding my output back. So the feedback design creates a closed loop gain, and you will learn these things in your, again, in your 4.1. There is a course on control system design. So this is how we can actually create a Butterworth filter. Okay, in your MATLAB, if you are familiar with MATLAB, we can actually design all these kinds of filter actually. Okay, these kinds of filter we can actually create those things. So I think this is okay for your special types of filters. In the next section, that will be our last section, there are some things that I didn't talk about, is called the RL filter. Okay, we didn't talk about that, and there are some applications I think we should actually look into those things. Okay.